Hi all, today we can study what is a cylindrical coordinate system. So a cylindrical coordinate system is the three-dimensional version of polar coordinate system. That means in cylindrical coordinate system we have three surfaces. One is a plane of constant z which is parallel to xy plane. Another is a cylinder of radius r with z-axis as the axis of cylinder. And third one is a half plane perpendicular to xy plane at an angle phi with respect to sz plane. So that angle phi is called as azimuthal angle. So we can say that in cylindrical coordinate system we are representing a point using three parameters, that is three planes, that is P of rho phi z, where rho is a we are imagining a circular cylinder having radius rho, then the radius of that cylinder is rho, then we are considering a vertical plane, that is that plane is perpendicular to xy plane, that makes an angle phi with respect to xz plane, or that make an angle phi from the x-axis, that is the second plane, and the height of that point is represented as z itself, that is the horizontal plane, z equal to constant. So we can see the cylindrical coordinate system. So you can see the three planes. One is that yellow represent a cylinder having radius rho, and that ash color represent a plane, horizontal plane, where z is a constant, and that blue represent the perpendicular plane, that is perpendicular to a plane that is perpendicular to xy plane, and that make an angle phi with x-axis, that is phi is equal to constant plane. So this is the cylindrical coordinate system. So the intersection of these 3 points represent a point in cylindrical coordinate system. So one more time we can say that any point in spaces are represented by 3 coordinates. P of rho phi z. Rho denotes the radius of an imaginary cylinder passing through P, or the radial distance from z axis to the point P. Phi denote azimuthal angle measured from x-axis to a vertical intersecting plane passing through P, that is the blue color region, and z denote distance from xy plane to a horizontal intersecting plane passing through P. It is the same as in rectangular coordinate system. So the plane that is similar to the rectangular coordinate system is the z plane. So these are the three planes we are using to represent a cylindrical coordinate system. Next is we can see the cylindrical coordinate system planes ranges. So the rho is a radius, so it should not be negative. So the range of rho is from 0 less than or equal to rho less than infinity. And phi is the phase angle. So the total phase angle is 360 degrees. So phi is measured in anti-clockwise direction with a range of 0 less than or equal to phi less than 2 pi. And z is the horizontal plane that represents the height of the point P, and that ranges from minus infinity less than z less than infinity. That plane is similar to rectangular coordinate system. In rectangular coordinate system, every plane, that is x equal to constant, y equal to constant, and z equal to constant, ranges from minus infinity less than in that x or y or z less than infinity. So we can see how we can represent a point in space using the cylindrical coordinate system. So this cylindrical coordinate system applications are in wires, to find the properties of wires or cables, etc. So we can represent a point of P of 345 8. That means P of 345 degree, 8. So we can represent that point as the intersection of when rho equal to 3, phi equal to 45 degree, and z equal to 8. So that's shown in figure. And a vector in this cylindrical coordinate system is represented as vector A equal to a rho cap plus a phi cap plus az cap. where a rho cap, a phi cap and az cap are the unit vectors along rho direction, phi and z direction. Then a rho, a phi, az are the magnitude or components of magnitude. And magnitude of the vector A is given by root of a rho square plus a phi square plus a z square. Next we can see the dot product and cross product of unit vectors in cylindrical coordinate system. So for same unit vectors, dot products are 1, different unit vectors dot products are 0. That means a rho dot a rho cap is equal to a phi cap dot a phi cap equal to a z cap dot a z cap, and which is equal to 1. Then a rho cap dot a phi cap equal to a phi cap dot a z cap equal to a z cap dot a rho cap, which is equal to 0. And for cross product we can use the clockwise direction as we seen in rectangular coordinate system. That means a rho cap cross a phi cap is equal to a z cap, a phi cap cross a z cap equal to a rho cap, a z cap cross a rho cap is equal to a phi cap. If you are taking the opposite direction, then it becomes minus. Then if it is same unit vectors, that means a rho cap cross a rho cap is 0. Next we can find what is the differential volume in cylindrical coordinates. Here the distance we can say that z and rho are in meters and phi in degrees. So to convert all the parameters in meters, the phi should be considered as the arc length. So that's why the side of the arc is rho, then the arc length is rho d phi. So we have the differential length, that is d rho, dz, rho d phi. Then the differential volume is rho d phi dz. That's the product of these three. And the differential length we can represent as d rho a rho cap plus rho d phi a phi cap plus dz a z cap. And area we can represent as the product of these two, d rho dz a phi cap, dz rho d phi a rho cap, or rho d phi dz or d rho d phi az cap. So these are the areas, differential areas. So we can find the differential volume as rho d phi dz. Next we can see what is the point transformation in cylindrical coordinates. That means how the cylindrical coordinates and rectangular coordinates are connected. So we can consider the point P. Then if we are extending that point P to the xy plane, that will intersect at a point. Then the height of that intersection to the point P is taken as z, and that point make an angle phi with the x-axis, and the side of that intersection side is same as that of the radius rho itself. So we have angle phi, and one side is hypotenuse is rho, then the opposite side is rho sin phi, and the adjacent side is rho cos phi. So we can say that in along y direction the rho component is rho sin phi, and along x direction we can say that the rho component is rho cos phi, and z is same as that of rectangular coordinate system. So we can say the relation as x equal to rho cos phi, y equal to rho sin phi, z equal to z itself. And the inverse relation is, we can take the equation number 1 and 2, then square equation number 1 and 2 and then add. Then you will get rho as root of x square plus y square, and divide equation number 2 with equation number 1. That means y by x equal to tan phi, or phi is equal to tan inverse y by x, and z is z itself. Next we can find the vector transformation in cylindrical and rectangular coordinate system. So here we seen that the rho has x along x direction the component is rho cos phi, and along y direction is rho sin phi. So take rho as 1, so you will get arrow component as cos phi along x direction, sin phi along y direction. There is no component along z direction, so that is 0. So the first row of the vector transformation is cos phi, sin phi, 0. And to obtain the phi component, you just add pi by 2 to the first row. So cos phi plus pi by 2, sin phi plus pi by 2, 0 plus pi by 2. There is no need of adding the phase angle. There is no phase angle parameter. So there is no need of any addition to 0. So you will get the phi component as cos phi plus pi by 2 minus sin phi. Sin phi plus pi by 2 cos phi. 0 is 0 itself. Then az is there is no its y direction, there is no az relation. Then az is same as that of z only. Then that becomes 1. So we can say that the relation arrow a phi az is equal to cos theta sin theta, cos phi sin phi 0 minus sin phi cos phi 0 0 0 1 into ax ay az. So this is the matrix equation that is used to transform one vector into another vector. So to find this first equation shows that the rectangular, we can convert the rectangular coordinate system to cylindrical coordinate system using this vector transformation. And to find the inverse, that means if you need to convert a cylindrical coordinate system to a rectangular coordinate system, you take the transpose of first equation. So transpose of first matrix cos theta sin phi 0 is cos phi minus sin phi 0, second row is sin phi cos phi 0, third row is 0 0 1 itself. So these are the vector transformation that is used to convert cylindrical coordinates to rectangular coordinates, similar rectangular coordinates to cylindrical coordinates. Next we can find the dot product. You can use the vector transformation or equation, or you can use the dot product of unit vectors in to convert a cylindrical to rectangular coordinate system or rectangular to cylindrical coordinate system. So x dot arrow is cos phi, then ay dot as dot a phi is minus sin phi, and x dot az is 0. So this is same as that of vector and dot product. You can see this second equation which is similar to this equation. So you can study either of this transformation to obtain the conversion from one coordinates to another coordinates. And next coordinate system, the spherical coordinate system, we can study in next video.